Welcome to day 6 of the Advent of Cyber 2023. My numbers are off, and that's a problem because we're going to see a lot of numbers. A lot of numbers for this particular challenge. People can see myself doxing myself by going through all the Chrome stuffs. Where did my Chrome go? Well, where did my Chrome go? Where is my Chrome? Anyway, this task unfortunately is once again pretty much inaccessible, because what they've done is they've made a game, and it's funny because I'm a game streamer on Twitch. My links are in the description if you're curious about that. But the funny bit is that I can't play this particular game. I literally come off a stream. I was just streaming it like 20 minutes ago. Playing a game I could play, and then this game I cannot play. And you can see that I've already filled in the question flag here, spoiler for someone who hasn't seen it yet, because I had to test if it worked first. I had to unfortunately resort to watching someone else do this room first, and then get the flag dictated from that video, and then hopefully there were no strange lead speak things in it for me to make it more difficult, which unfortunately there were not. I will read it out loud once we get to that portion, but people who've already seen it, well, I guess if that's what you came for, bye, have a good day. Apart from that, though, we need to go through essentially what we have today is a buffer overflow challenge. So I'm going to start the machine so you can at least see what it looks like. And for the people who haven't done this room or want to see what it's like. Yeah, basically it's a game in another tab, so we'll open it up once it's started, and in the meantime I'll start reading the stuffs. We have a task banner for day 6, still don't know what those mean. Throughout the merger, we have detected some worrying coding practices from the South Pole elves. To ensure their code is up to our standards, some frostlings from the South Pole will undergo a quick training session about memory corruption vulnerabilities. All courtesy of B-Team. Welcome to the training! ! Learning objectives. Understand how specific languages may not handle memory safely. Understand how variables might overflow into adjacent memory and corrupt it. Exploit a simple buffer overflow to directly change memory you are not supposed to access. Connecting to the machine. Before we move forward, preview the questions in the connection cards shown below. The connection card was actually not here when I initially looked at the room. It's here now. It says, what should we do today? The connection card details says, start the target machine. A thmlabs.com direct link is available. That's true because this is a web app. Be sure to hit the start machine button at the top right of the task before continuing. All you need for this challenge is available in the deployable machine. Once the machine has started, you can access the game at link 10.10.50.29.b.thm.com. I don't think it's up yet, so we'll give it a minute. If you receive a 502 error, please give the machine a couple more minutes to boot and then refresh the page. The game. This is where it gets inaccessible, unfortunately. In this game, you'll play as cat or mouse. Your objective is to save Christmas by buying the star for your Christmas tree from Van Frosty. In addition to the star, you can buy as many ornaments as you can carry to decorate your tree. To gain money to buy things, you can use the computer to do online freelancing programming jobs. You can also speak to Van Holly to change your name for a fee of 1 coin per character. He says that this is totally not a scam. He will actually start calling you by your new name. He is, after all, into identity management. Look at that, a little pun. Okay, I think the game is done by now, so let's open that up real briefly to show what we can do here. So yeah, really all the screen reader sees is this.
Graphic clickable, graphic clickable, graphic clickable, graphic clickable, graphic clickable.
That's it. Graphic clickable. It's
No
I think web canvas. They say later it's written in C++. The UI, I'm not sure what it is. It might be OpenGL or some other thing.
No next, no previous, no objects and adds graphic.
What we can see in the graphic, here's the OCR result.
Builder.
builder,
Press to continue.
press to
Press to
continue.
continue. Press to continue.
I
Graphic
figured
clickable.
out earlier that that means press space to continue. We will do that.
Graphic recognizing. Interact slash speak.
Interact and
Game,
speak.
enter debug panel.
Debug panel is
Move.
tab, move, we
Use
don't
it.
know, use.
Reset inventory.
A reset inventory
Press to
is a
continue.
button, and then press space to continue. We
Graphic
can't see what the buttons are because those are icons, not bits of text. This is why we
Graphic.
shouldn't use images of text,
Recognize
people.
11. Regame. To finish the
The
game. all you
game.
need
To
do
finish
is
the
get a star
game,
to
all
put-
you need to do is get a star to put upon your Christmas tree.
Advent of site. Graphic recognizing. Regame. After you get the star.
After
just
you
interact
get
with
the
Christmas
star,
tree.
just interact with the Christmas tree, and that's it.
Graphic
Okay,
click.
well, whoop,
Recognizing. Use it. Reset in. And press to continue. Graphic
press
click of
space
graphic.
to continue. We will
Graphic
do
clickable.
that.
Graphic. Recognize 11. Regame. You are free to buy as
You
many
are
additional
free to
ornaments
buy
you
as many additional ornaments as you can carry to customize your tree.
Graphic click. Graphic recognize 11.
And that's it, really. That's all we can really
Clickable.
do. You can walk around a little bit. There's no sound. There's no way that you actually know that you're next to something you can interact with. We'll press space here. Does
Recognizing result.
that do
Graphic.
anything? I doubt
Graphic
it.
clickable. Graphic recognize 11.
No. Okay, so
Graphic clickable.
that's as far as the game goes, and it's really a shame. We can show off the debug panels. We can press tab, show off the little debug panel here, and we have a hex view, and we have a nothing view. There we go.
Try
That's really as far as the game goes. Unfortunately, it's a shame because I wish they would have done. Well, so this is a reskin, I'm pretty sure, from a game from last year where you had a very similar sort of challenge with, I think it was a guard that you could trick to do name things. It's really reminiscent of what we did last year, and it wasn't accessible then either, so it's not a surprise that it isn't now either. And again, just like yesterday with the DOS emulator, while it is absolutely possible to make this accessible, it is not necessarily always very practical. Like they could have done this into a text adventure kind of style if we're going the DOS like route anyway. Maybe they could have added some audio cues or something, but really that's not the point of the game. The point of the game is, and we'll see this later, is actually very visual as well in some respects. So making this accessible would have been very difficult. For now, let's just go through the material, because there are a couple things that we can do, and if you understand what's being explained, then you should be pretty okay. It's all about memory and memory corruption, so let's learn a bit more about that. What's the next section? Yeah, here. There's a graphics here that says game overview as the alt text. We can't see anything else for that.
Speech mode off.
And then we get, is this a bug? Van Holly, an image with Van Holly as the alt name. Before the training even starts, Van Jolly. Wait, oh no, I misread that. Not Van Holly, Van Jolly. Sorry about that. Van Jolly approaches McHoneybell and says that they've been observing some weird behaviors while playing the game. They think the ghost of Christmas past is haunting it. McHoneybell asks them to reproduce what they saw. Van Jolly boots up the game and does the following, which you are free to replicate too. 1. Use your computer until you get 13 coins. Ask Van Holly to change your name to Scrooge Rocks with an exclamation point. Suddenly you have 33 points out of nowhere. Van Jolly explains that when you change your name to anything large enough, the game goes nuts. Sometimes you'll get random items in your inventory, or your coins just disappear. Even the dialogues can stop working and show random gibberish. This must surely be the work of magic. McHoneybell doesn't look convinced. After some thinking, she seems to know what this is all about. Memory corruption. Remember that whenever we execute a program, this game included, all data will be processed somehow through the computer's RAM, random access memory. In this video game, your coin count, inventory, position, movement speed, and direction are all stored somewhere in the memory and updated as needed as the game goes on. Memory layout. So this is a memory layout which has a couple of labels in it: coins, position Y, position X, games memory. Yeah, it's pretty much. They should have done actually a little bit more with the alt text here, because this is literally just has the alt of memory layout, but this is a visual sort of, I'm assuming it's like a grid pattern where you can see some things sort of right next to each other. Usually, each variable stored in memory can only be manipulated in specific ways as the developers intended. For example, you should only be able to modify your coins by working on the PC or by spending money either at the store or by changing your name. In a well-programmed game, you shouldn't be able to influence your coins in any other way. But what happens if we can indirectly change the contents of the memory space that holds the coin count? What if the game had a flaw that allows you to overwrite pieces of memory you are not supposed to? Memory corruption vulnerabilities will allow you to do that and much more. Honeybell says the debugger will be needed to check the memory contents with that while the game runs. Wow. Talking is hard today, sorry guys. On hearing that, Van Sprinkles says they programmed a debug panel into the game that does exactly that. This will make it easier for us. Accessing the debug panel, okay, while they were developing this game, the Frostlings added debugging functionality to watch the memory layout of some of the game's variables. They did this because they couldn't understand why the game was suddenly crashing or behaving strangely. To access this hidden memory monitor, just press tab in the game. We just showed that off. You can press tab repeatedly to cycle through two different views of the debugging interface. ASCII view, the memory will be shown in ASCII encoding. It is useful when trying to read data stored as strings. Or a hexadecimal view, the memory contents will be shown in hex. This is useful in cases where the data you are trying to monitor is a raw number or other data that can't be represented as ASCII strings. Yeah, we see a screenshot of that with an image with the alt text debug panel, so I'm assuming that just shows off what we just showed off. Okay. Viewing the contents in RAM will prove helpful for understanding how memory corruption occurs, so be sure to check the debug panel for each action you make in the game. We can't. Remember, you can always hide the debug panel by pressing tab until it closes. Armed with the debugging panel, McHoneybell starts the lesson. As a first step, she asks you to restart your game, refreshing the website should work, and open the debug interface in hex mode. The Frostlings have labeled each of the variables stored in memory, making it easy to trace them. Van Twinkle, apparently. We have an image of Van Twinkle with the alt text of Van Twinkle. McHoneybell wants you to focus your attention on the coins variable. Go to the computer and generate a coin. As expected, you should see the coin count increase in the user interface and the debug panel simultaneously. We now know where the coin count is stored. McHoneybell then points out that right before the coin's memory space, we have the player name variable. She also notes that the player name variable only has room to accommodate 12 bytes of information. But why does this matter at all? Asks a confused Van Twinkle. Because if you try to change your name to Scrooge Rocks ! You would be using 13 characters, which amounts to 13 bytes, replies McHoneybell. Van Twinkle, still perplexed, interrupts. So what would happen with that extra byte? At the end, McHoneybell says it will overflow to the first byte of the coins variable. To prove this point, McHoneybell proposes replicating the same experiment, but this time we will get 13 coins and change our name to AAAABBBBCCCCX. Meanwhile, we'll keep our eye on the debug panel. Let's try this in our game and see what happens. All of a sudden, we have 120 coins. The memory space of the coins variable now holds 78. We have an overflowing coins alt text image. Remember that 0x78 in hexadecimal equals 120 in decimal. To make this even clearer, let's switch the debug panel to ASCII mode. Overflowing coins in ASCII mode. In alt text. The X at the end of our new name spilled over into the coins variable. The ASCII hexadecimal value for X is 0x78, so the coin value was changed to 0x78, or 120 in decimal representation. As you can see, McHoneybell's predictions were correct. The game doesn't check if the player name variable has enough space to store the new name. Instead, it keeps writing to adjacent memory, overwriting the values of other variables. Fun fact, this is also how you could do a lot of Pokemon hacks in the really early games. This is how like you get super strange like screen glitches and Pokemons with weird names and things like that. This vulnerability is known as a buffer overflow and can be used to corrupt memory right next to a vulnerable variable. Buffer overflows occur in some programming languages, mostly C and C++, where the variable's boundaries aren't strict. If programmers don't check the boundaries themselves, it's possible to abuse a variable to read or write memory beyond the space initially reserved for it. Our game is written in C++. Strings in more detail. By now, the Frostlings look baffled. It never occurred to them that they should check the size of a variable before writing to it. Van Twinkle has another question. When the game started, the main character's name was Cat or Mouse, which only uses 10 characters. Analyzing player name. Graphic with alt text of analyzing player name. How does the game know the length of the string if no boundary checks are performed on the variable? To explain this, McHoneybell asks us to do the following. Restart the game, get at least 3 coins, change your name to Elf. As a result, your memory layout should look like this. Changing name to Elf is the alt text for the memory list. You could do better here, guys. Come on. Oh.
Speech mode game overview graphic van memory lit debug van twinkle graphic click overflowing coins as analyzing player name changing name to Elf graphic click speech mode off.
Had to find my place. When strings are written to memory, each character is written in order, taking a 1 byte each. A null character, represented in our game by a red 0, is also concatenated at the end of the string. A null character is simply a byte with the value 0x00, which can be seen by changing the debug panel to hex mode. When reading a variable as a string, the game will stop at the first null character it finds. This allows programmers to store smaller strings into variables with larger capacities. Any character appearing after the null byte is ignored, even if it has a value. To better explain all this, McHoneybell proposes a second experiment on strings. Get 16 coins, rename yourself to AAAA BBBB CCCC DDDD, 16 characters. Now, your memory layout should look like this. Oh, I don't even see a name. Oh, no, there is one. Graphic 16-bit overflow is now the alt text. Notice how the game adds a null character after your 16 bytes, which overwrites the shopk name variable. If you talk to the shopkeeper, you should see his name is now empty. Oh, he no longer has a name. That's rude. Shopkeeper without a name, graphic with alt text. This happens because the game reads from the start of the variable up to the first null byte, which appears in the first byte in our example. Therefore, this is equivalent to having an empty string. On the other hand, if you talk to Van Holly, you should see your own name is now AAAABBBBCCCCDDDD, which is 16 characters long. Player name overflown. Since C++ doesn't check variable boundaries, it reads your name from the start of the player name variable to the first null byte it finds. That's why your name is now 16 characters long, even though the player name variable should only first fit 12 bytes. Part of your name now overlaps with the coins variable, so if you spend some money in the shop, your visible name will also change. Buy some items and see what happens. Integers and the coins variable. Van Twinkle mistyped the name during the previous experiment and ended up with AAAABBBBCCCCDEFG. That's a serious typo there, friend. You might want to have that looked at. They then noticed that they had... I hate you. 1,195,787,588 coins in the upper right corner, shown as follows in the debug panel. The screenshot with the alt text understanding integers. Out of curiosity, they used an online tool that converts hexadecimal to decimal numbers to check if the hexadecimal number from the debug panel matched their coin count. To their surprise, the numbers were different. Hex to decimal converter. We don't know what's in the screenshot. Honeybell explains that integers in C++ are stored in a very particular way in memory. First, integers have a fixed memory space of 4 bytes, as seen in debug panel. Secondly, an integer's bytes are stored in reversed order in most desktop machines. This is known as little endian, byte order. Let's use an example to understand this better. If you take your current coin count of 1,195,787,588 and convert this number to hex, you'll obtain OX bracket 47464544, corresponding to what's shown by the debug panel but backwards. How many coins would you have if the hex value of the coins variable was showing in memory as the following? Input your answers at the end of the task. Graphic that just says overflowing coins. Don't do this, guys. Don't worry, you redeem yourself later, but don't do this. This is not helpful alt text at all. Overflowing coins. Please just, like, do it over. Like, go into the tasks, questions, get the alt text from the actual image there, and then paste it here. This is just bad. Winning the game. McHoneybell is about to wrap up the lesson and call it a day. But first, she explains how an attacker could now override any value to the coins variable and have enough to buy this star and finish the game. On hearing this, McGreedy starts laughing maniacally and tells McHoneybell that McHoneybell is more than welcome to try to purchase the star, McGreedy says. Confused, McHoneybell does some quick calculations and concludes that she should be able to get enough coins. She looks at you and asks you to show how the vulnerability can be exploited. You notice that she looks a little doubtful, but still, it's now up to you to win the game. Can you get a star in your inventory and prove McGreedy wrong? Getting a star. Once you get the star, interact with the Christmas tree to finish the game. I have seen so many questions on Discord about how to do these things that it's very clear that a lot of people don't read the entire text. But the problem is, I think there's some kind of trick to getting this star to work. Normally you just get 10,000 coins, you get it, but apparently that doesn't work. I don't know what the gimmick is here, because that's a part of it we just cannot do excessively, unfortunately. So, leaves us the questions. If the coins variable had the in-memory value of the image below, how many coins would you have in total? So in this case, we have an alt text of 4F, 4F, 50, 53. So what we now need to go do is we need to go to hexadecimal to decimal converter. We'll probably end up on crack tables or some on crack station or rainbow tables or something. Oh, yeah, your rapid tables, there you go. Okay. So we have... Oh, that's cute. What's going on? Where are we? Google. Where'd the challenge go? There it is. Okay. So, yeah. Oh, here's the game. Yeah, okay. So, here's the actual thing. 4F, 4F, 50, 53. But remember, little endian, so we have to do this in the other way around. 53, 50, 4F, 4F. So we go into here. We do... What was it? 53, 50, then 4F, 4F. Okay. 53... Oh. 53, 50, 4F, 4F. And then we press convert. which brings us at a number of 1,397,000, 1,397 1,397,772,111. So 139777211. And we're gonna paste that in the question box to see if we did it right. Did we do it right? Yes, we did. Very nice. That's the correct answer. So 139777211. Sorry, 10 digits. 139777211. What is the value of the final flag? Now, this one I did beforehand because I wasn't sure if I had the right spelling of it, but it's THM left brace McHoneybell with capital M, capital H, underscore is underscore the underscore real underscore star right brace. We have only explored the surface of buffer overflows in this task. Buffer overflows are the basis of many public exploits and can even be used to gain complete control of a machine. If you want to, feel free to check the buffer overflow room. Okay, let's just say we did that. Vanjali still thinks the ghost of Christmas past is in the game. She says she has seen it with her own eyes. She thinks the ghost is hidden in a glitch, whatever that means. What could she have seen? We don't know. That's something in the game that we can't replicate, but fortunately we don't have an answer to fill in. We just press the button and say that we did it. So with that, that is this task done, unfortunately. 2 inaccessible ones in a row. Hopefully this isn't going to be a trend. I hope it's going to switch back to good old, quote, regular, quote, hacking soon. But for now, this is what we need to do. This is the end of the task. Hope this was helpful. Bye.